There are basically four parameters in this particular concept of using a number line for weighted average. The first component with a rate of R1 is mixed with the second component with a rate of R2. In the mixing ratio, the quantities are Q1 and Q2, so the mixing ratio is Q1 by Q2. That's just one variable, it's not two variables. And you will get a weighted average, which I'm going to denote as RW. So there are four parameters here, right? What we have seen till now, so let me just list those four parameters: R1, R2, RW, and Q1 by Q2. If you're given any three, you will be able to find the last one. For example, just think about area is equal to length into breadth, right? Three parameters are there: area, length, and breadth. You know that if you're given length and breadth, you can find the area. If you're given area and length, you can find the breadth. And if you're given area and breadth, you can find the length, right? Any one unknown can be found because there is a relation between the three parameters. That's all I'm talking about, right? So till now, we were looking at examples where the rates of the components are given, the mixing ratio is given, the weighted average is the unknown. But we could also have situations where the attribute of the mixture is also given along with the components. What is the ratio in which it is mixed? You could also have a situation where one of the two rates is given, the weighted average is given, the mixing ratio is given. What was the other component that was mixed? These two possibilities are also there. Let's look at examples. The question says, students of division A scored an average of 32 on a test, while those of division B scored an average of 38. If the average for the whole batch was 35.2, what is the ratio of the number of students in division A and B? Now this 35.2 is the weighted average of 32 and 38. So basically what we have here is a situation where there are two components being mixed. The first component has a rate of 32 marks per person, that's an average. 38 marks per person, that's your second rate, and your weighted average is 35.2. What's missing is the mixing ratio. What is the number of students in division A and the number of students in division B? What is the ratio between that? So in this case, what you would do is you will, instead of going from the mixing ratio to the distance ratio, by which I mean distance on the number line, you go in the reverse direction. You look at the distance ratio first. It's clearly 3.2 and 2.8. That ratio, it simplifies to 32 is to 28, which further simplifies to 8 is to 7. You flip it and you will say that the number of students in class A and class B would be 7 is to 8. You just put the three rates on the number line, subtract to find the distance ratio, and flip that to get the quantity ratio. That's how you find the unknown quantity ratio. Here is an example where one of the two components that are mixed is missing. The average height of 30 students is 156 centimeter in a class of 40 whose overall average is 160 centimeters. What is the average height of the remaining 10 students? So what we basically have is, you have the overall average is the weighted average, that's in between 160, and the first 30 students have an average of 156. So clearly the remaining 10 students should have an average higher than that. The weighted average should always lie in between the components. Now you have a total of 40 students, of which 30 students have an average of 156. So the mixing ratio is 30 is to 10. So that would simplify to 3 is to 1. Flip that ratio and you'll get 1 is to 3. Now the one part corresponds to 4 units, the distance between 156 and 160. So the 3 parts should clearly correspond to 12 units by direct proportion. So the required answer is 12 units to the right of 160. So 172 centimeters would be your answer. 172 centimeters is the average height of the remaining 10 students.